Hello and welcome back. Let's finish up by finishing up this example and doing one more. So we were seeing last time that we have a plane that's trying to fly at 100 miles an hour with a bearing of 0 degrees from north, so it's trying to fly exactly due north. But there's a wind that's blowing it in a slightly different direction. The wind is blowing 20 miles an hour, so not quite as fast as a plane is trying to fly, at a bearing of 170 degrees from due north. So 180 degrees is straight back, so 170 degrees is a little bit less than that, so it'll be pointing more south and a little bit east. So we drew our vectors, the airspeed of the plane pointing due north with a length of 100, the wind pointing at 170 degrees from due north, but with a length of 20 degrees. And in order to find the resultant, this is going to be the sum of those two vectors. So we drew our parallelogram, and we noticed that, some of these angles we know. We know that the 170 degree angle is here. The opposite interior for having parallel lines gives us this angle is 170, and the angle sort of next to it is going to be a supplementary angle. They're going to add up to 180 degrees. So that's going to be a 10 degree angle, that's going to be a 10 degree angle. And with all that being said, we have our triangle here. So this is just the top triangle. It's 100 long with a 20 degree side right there and a 10 degree angle between them. So that means that using the law of cosines, I can find this angle right here. So let's use the law of cosines. And again, if I call this side A, this side B, this side will be C, and this angle up here is going to be capital C. And we have C squared is going to be equal to A squared plus B squared minus 2AB cosine C. So plugging in our numbers, we'll have 100 squared plus 20 squared minus 2 times 100 times 20 times cosine of our 10 degree angle. And solving for all that, got 100 squared plus 20 squared minus 2 times 100 times 20 times the cosine of a 10 degree angle. And that's going to be 6,046. I'll round it to 6,461. But I don't want to round it until I finish this up, because that's going to be equal to C squared. So C itself is going to be the square root of our previous answer. So it's going to be 83, and I'll round that to, 80 point, I'll round that to 4. Do one decimal place. 80.4. So since the wind is blowing nearly straight backwards, it nearly subtracted 20 miles an hour from the speed. But not quite, and it's actually going 80.4, so a little bit more than 80 because it's not quite straight backwards. So this is going to be miles per hour, and this is going to be the ground speed. For our plane. So if you're trying to fly 100 miles an hour due north, but you've got a 20 mile an hour wind blowing nearly due south, we'll be going a little bit more than 80 miles per hour. Only a little bit though. The last thing that it asks us to do is calculate the bearing of the plane. So the bearing in terms of the ground speed. So in our picture up here, we're going the plane is trying to fly due north at 100 miles an hour, but is actually flying about 80 miles an hour in this direction here. So the bearing is going to be the difference between due north and the actual direction you're going in. So what we're doing is here, I want to know this angle. So this angle is going to be the bearing that the plane is flying in. It's the difference between the direction the plane is flying in and due north. So that angle is just this angle right here. And there are a few different ways that we can do this. Since we're using the law of cosines, I'm going to use the law of cosines again. And so here I've called them all A, B, and C. We know what C is. We figured that out. This angle, I don't know, but this is going to be across from B, so it's going to be capital B. So if I want to use the law of cosines and figure out capital B, I know that if I have the cosine of B, I want the opposite side to be on the opposite side of the equation. So it's going to be a squared plus c squared minus 2 times a times c. And now I can use the law of cosines to figure out that angle. So if I try to solve for the law of cosines, if I try to solve for the cosine of b, I could move these guys to the other side and get b squared minus a squared minus c squared is equal to minus 2 times a times c times cosine of b. And then I'll divide both sides by negative 2ac. So cosine of b is going to be b squared minus a squared minus c squared over negative 2ac. So let's figure that out. We have b squared was this guy, which we still have in our calculator. So what I'll do is I'll just hit enter. So this was our b. So I'll put this into a fraction, and I'll take this guy squared minus a squared minus oh, excuse me, it was b squared, wasn't it? I have already made a mistake. So b was 20, and c was the one that we figured out last time. So we have b squared minus a squared minus c squared all over negative 2 times a times c, which was this answer right there. So our this is going to be our cosine. So 0.999, very close to being 1. And then for b, if I want to move the cosine to the other side, I take the inverse cosine. And luckily Desmos can do that for us. Desmos has the inverse cosine function, and I'll just take the inverse cosine of that last answer. And we get, so if I round it to the nearest tenth, this is going to be 2.5. And again, so that's 2.5 degrees. So the plane hasn't been pushed very much off of due north. It's only going 2.5 degrees to the east. So a 20 mile an hour wind hasn't really affected our plane very much, especially because it's flying 100 miles an hour. 20 miles an hour is almost insignificant. Let's do one final example. An object experiences, and I misspelled two forces, a 15-pound force and a 20-pound force. But we know that the total force, the resultant force, is 30 pounds. So the question is, what's the angle between the two forces? So when forces are pushing against each other, they're going to cancel out. If forces are pushing in the same direction as one another, they're going to add up. We're going to experience more force. So here, a 15-pound force and a 20-pound force, giving a resultant force of 30 pounds, that means that they should be pointing in about the same direction. They're adding up quite a bit. They're not canceling each other out a whole lot, but exactly what's the angle between them? So we can draw a picture. We've got our 15-pound force. We've got our 20-pound force. And we know that the resultant force is 30 pounds. Well, the resultant is going to be the sum of those two forces. This is going to be 30 pounds. Well, again, just like anytime we're working with vectors. So again, a 15-pound force and a 20-pound force, these are vectors. We want to add the vectors together to get our 30-pound force. We can draw our parallelogram, and we know all of these side lengths because those vectors are equal and the two sides are equal. And oh look, there's a triangle. So what we want to do is find the angle here. The angle between our 15-pound force and our 20-pound force. So the trick here that I'll let you know, if we find this force up here, or this angle up there, this is the supplementary angle. So it's useful if we can figure out that force, or this. Sorry, I keep misspeaking. This angle, because this is just the supplement of it. The angles opposite one another are going to be equal. So this angle and this angle are the same. That angle and that angle are the same. And these guys add up to 180. So if I know that one, it's pretty easy to find this one. So let's find that angle there. And again, I'm going to use the law of cosines. So if I call that guy C, if I call this guy A and this guy B, I know that C squared is going to be equal to A squared plus B squared minus 2AB times the cosine of the angle between A and B, which is the one that I want. So if I try to solve for the cosine of C, just like I did before, maybe I'll skip some of those steps. It's going to be C squared minus A squared minus B squared, so moving the A and the B to the other side. And then I have to divide by negative 2AB. So let's come back to Desmos. And we've got 30. Let's see here. Let's make a fraction. And we'll take 30 squared minus 15 squared minus, was it 20 squared? Just want to check and make sure. Yep, A was 15 and B was 20. All divided by negative 2 times A times B. Cool. So this is, so we get negative, let's round that to 4.6. Sorry, 0.46. And then if I want C by itself, I'll take the inverse cosine of both sides. I don't want to plug in just negative 0.46 because I've rounded too early. I don't want to round to the very end. So I will take the inverse cosine, and Desmos remembers exactly what that number is, so I'll just plug that in. Enter, and I get 117 degree angle, and I'll just round it to that. Okay, so this is the angle C. This is not the angle between our two forces, because the angle between our two forces is actually the supplement of this guy. So if I take 180 minus 117, 100s cancel out, 80 minus 17 will be 53. So there's a 53 degree angle, between our two forces, which is why the 15 and the 20 don't combine to give us exactly 35 pounds of force, but a little less.